I attempt answering this question. I'm gonna go as slow as I can. Hopefully it doesn't drag the video too much. But yeah. Okay, let's look at 5.1. 5. Before we even look at 5.1, let's read the information that we have here. So we've got h of x, which is equal to a to the x. A is positive. We are being told a is never 1. We've got a point B, which is negative 1.5, which lies on h and the graph of h of x. So we can clearly know that this is an exponential graph, and we can try write down everything that is here, right? So determine the value of a. Every single time if it says determine the value of a, just check for the coordinate that you've been given there, right? Substitute it, then find the value. So we know that h of x is just a to the x. Our y value is half, and a is just a to the power minus 1, right? What we can do here is we can write down this such that it has a root that is equal to negative 1, not a root, it is an exponent that is equal to negative 1, right? So this is just, you can write it as 2 to the power minus 1 is equal to a minus 1. You see now they've got the same exponent, so that means a is just 2. We're good to go there. Answer the first one. Now write down the equation of h to the power minus 1, which is just the inverse, right? In the form y is equal to. So if you want to write that down, this is just, it's very, very, very simple. First, let's start with h. H of x is 2 to the power x, right? 2 to the power x. So we start with just y is equal to 2 to the power x. Interchange the 2, so x is equal to 2 to the power y. Now take your logs. Y is equal to log base 2 x. Done. That answers number 2. Sketch the graph of h and its inverse on the same set of x's, showing everything that is definitely needed for you to show. So this is an increasing graph, right? Remember, a in this case is positive, is greater than 0, and b is actually greater than 1. So it should pass through a point here, 0 and 1. We can definitely look for another point when x is 1. This will actually tell us what happens when x is 1. X is 1, then y is 2, right? So x is 1, y is 2. So our graph is going to be something like this. Okay, you can actually just show that point 1 and 2. Of course, our asymptote is y is equal to 0. I'm sure you've already seen that. It's just on the x-axis. That's just it. That is the graph. Now, if you want to draw the inverse, remember everything changes up. This now becomes 0 and 1. So it will be somewhere here, 0 and 1. And this now becomes 2 and 1. So it's right. So it's going to be somewhere here again, 2 and 1. Oh, it's going to be here, 2 and 1. So it means our graph is just something like this. That is graph of that. You actually have seen that all the coordinates have now interchanged, but that is just it. Next up is write down the domain of the inverse of h. The domain of the inverse of h, again, this we're looking at all the x values, right? How are they? So 5.4, this was 5.3, 5.2, that was 5.1. If you want to answer 5.4, the domain, look at the x values of this thing. All of the x values are actually greater than 0. It will never be 0. It will never be negative. So all of them are just greater than 0, right? We're talking about the x values here. So the domain, that means x. Oh, I'm actually trying to convince myself that whatever I'm saying is correct. So x has to be greater than 0. That's my proposal. So I'm proposing that all the values for your domain that's positive. So this you'll find it from say the range of f. The range of this one is just y greater than 0, right? So if you take the inverse, x is just greater than 0. That's just it. Now next up, it says determine the values of x for which h of the inverse of h is now greater than 0. So simple thing, you'll go where you can go where y is actually 1, which is going to be this point on your inverse, right? So we want all the values where it's actually greater. So it's just your x value here is 2. So that means when x is greater than 2, then that condition is satisfied. So your answer is just our x values should be greater than 2 for our graph, for our inverse to be actually greater than 1. So that's just it. There we go. We want to go for 5.6. 5.6 describe the shift from h to t. So okay, we're moving from h to t this time around. You want to know what happened. If you check, we didn't have a lot here, right? We just had 2 to the x only. So two things happened. For us to shift down there, a negative was definitely introduced and 1 was definitely subtracted. So that means here we shifted our graph, we reflected our graph, reflected about the line, no, it's not the line, right, about the x, about the y-axis, because x now has a negative y-axis, and shifted this now reflected about the y-axis, and it's now shifted 1 unit. I'm sure you've guessed it, we've subtracted, so to the left. No, 1 unit down, sorry, 1 unit down. Remember, this is q being affected, so it's up and down. That is 5.6.1. To answer 5.6.2, the asymptote of t, that's just simple, y is equal to -1. Done.